Okay, this week's an exam on Friday. The checklist has a lot of problems to try. It is in two parts. The take home is already up. The in-person has 5 questions on it. And on My Math Lab, it's not for a grade, but there are practice problems. So we'll go through those 5 today. And then you can always go on My Math Lab and try another, and it'll give you similar problems, and that way you can practice them more. You can use a formula sheet. And any questions? The e-text, that's on My Math Lab, and then you just click and the book will open. These are problems that we used when I was explaining the material. And these are all good problems to try. If you need help with the take-home portion. And then it kind of just tells you everything that's on the test. I put some sample ones here at the end just for more practice, but I want to do the 5 that are on the in-person portion first. This formula here, we'll do a problem like this today. The average cost function, you divide it by X. And then I think we find a limit to infinity. The definition of the derivative, that's the limit as h approaches 0, f of x plus h minus f of x all over h. Marginal profit, revenue, marginal revenue, and marginal cost, all of those are the derivative. Revenue is price times quantity, and profit is revenue minus cost. Is this sheet? Yes, this sheet is the checklist on As You Learn. Also, I put some recordings from last semester under Media Gallery. And they'll say review for in-person portion of the exam. One was where something's discontinuous and finding limits. So there's a few videos that I put up there from previous years. That way then you can see more practice. At one time there was 7 problems on the in-person, but some of them kind of repeated, so I took them off. So you may see more problems on that one. And they're still covered, it's just not on the in-person. So on My Math Lab, this is up there. It says review for exam 2, not for a grade. These are similar to the in-person portion of the exam. There's 5 questions and there's 5 on here. So we'll go over these first, then we'll do the ones on this handout. And I think that will take up most of today. And then look at the take home and see where you have questions. Okay, so the first one on here. The total revenue function for a product is given by this function, and the total cost is given by this. Where C is measured in dollars, the input X for the number of units produced. Oh, okay, for both functions, the input is the number of units produced and sold. So we're in dollars. And X is number of units. Form the profit function. So the first thing we want to do is find the profit function. What you need to remember is profit is revenue minus cost. So if you have a formula sheet, that's one of the ones you would want on your formula sheet. The biggest thing is, remember, subtract all of the costs. So if we look at our revenue, 540x minus our cost, this negative has to distribute. You're not just subtracting the 13,500. So make sure you put parentheses and distribute it. This will equal our profit. So a negative x squared. 540 minus 60x. I put my x squared first, so this negative times a positive will make it negative x squared. And then my x term, I have 540x minus 60x. And then the negative 13,500. That would be the profit function. Any questions on that part? When 22 units are produced and sold, there's a profit of how much? I don't know why they're putting. Oh, it says right here, what is the profit when 22 units are produced and sold? Remember, X is the number of units, so we plug 22 in for X. Two squared. So for this part, they want loss or profit. Notice when you plugged it in, did you get a negative answer? Should get a negative 34.24. Oops, I put that down in the wrong one. That's a loss. Because it's a negative, it's a loss of 3,424. If it were a positive, then it'd be a profit. Any questions? Okay. The next one, when 37 units are produced and sold, again, units, that's your X value. So you just plug it in for X. And this one, did you get a positive 28.91? Because it's positive, it's a profit. Any questions so far? How do you determine if it's a? When I plugged this one in, I got a negative answer. It was a negative 34.24. That's what makes the loss, the negative sign. This one was a positive 28.91. That's what made it a profit. So a negative sign is a loss. A positive is a profit. Any questions? Find the number of units that must be sold to break even on this product. To break even, profit equals 0. And that's another formula you can put. You either set profit equal to 0 or revenue equal to cost. Since we had to find the profit function, it's easier to set profit equal to 0. So we have negative x squared plus 480x minus 13,500 equals 0. Now, you could try and factor it. The numbers are so large, I don't even want to start with it. I would use the quadratic formula. You have ax squared plus bx plus c equal to 0. And that's why I said use profit equals 0, because otherwise we would have had to get it equal to 0. So to find x, quadratic formula is negative b plus or minus the square root b squared minus 4ac all over 2a. Even if you have it memorized, it might be something you want to put on your formula sheet. In our problem, a is with the x squared term, so it's a -1. B is 480 and C is a negative 13,500. And then just plug in. So negative B plus or minus the square root 480 squared minus 4 times A times C. All over 2 times A. I like to calculate under the square root first. 480 squared minus. Any questions on that part? So I just calculated under the square root. Then you could take the plus. And find that value. And the minus. You should be getting 30 and 450. These are both break-even points. This one's the minimum break-even point. This is where you start making money. That's where you start making money. You're no longer at a loss. This one is the maximum break even. This is where you start losing money again. This is when the new model comes out. The cost is positive. The cost is going like this. The revenue goes like this. So that first one at 30, that's where revenue was above the cost. But then notice here, cost goes higher than the revenue. This one, the 450, is when your cost is a lot higher than what you're making your revenue. So here's where you start making money, and in here, you're making money. And then right here is where you start losing money. You need the new version or the new model to come out. Yes, you could use Desmos for your calculator. You won't need it for graphing. You won't have to graph this. But I think I might ask what the importance of the points are. This one is the lower value is where you're no longer at a loss and you start making money. This is the one where you're not making a profit anymore, you're at a loss, so you need a new model to come out. Any questions on that? But you can use Desmos. Solve the equation algebraically and check. You do not have to check it graphically. It's just solve the equation. So when we have an equation where the variable is in the exponent, we want to take the natural log of both sides, because remember, the natural log x to the r, you can bring that r down in front. But we want to get the e by itself first. So if we divide both sides by 2, we have e to the 7x equals 721. Probably should have done it. To get rid of the exponential function, since this is an e, it's even nicer than this one. E to this to any variable, the exponentials cancel. So both of these are formulas you probably want to put on your formula sheet. Since this one is an e, we can take the natural log of both sides. Because these are inverses, they cancel. And then divide by 7. A lot of times I'll ask for the exact value and then the decimal so that I know you're solving it. So this would be exact value. And then plugging that into your calculator. I don't know what I did on the test, but let's round to the 100th. The natural log button, it's here. Sometimes they're up here, but you want ln. $7.21. Make sure you close the parenthesis before you divide by 7. So it looks something like this. The 100th is the second position. And this is a 0, so it would be 0.94. Any questions on that? So it's just solving an exponential function. When we get into finance, we're going to use this a lot to find when things are doubling. Any questions on that one? The third one, sorry, the printer started to fade on this one. The supply function for a certain size boat is given by P equals 570 times 2 to the Q, where P is dollars. Dollars is the price of the boat, and Q is the quantity of boats sold at that price. So Q is the number of boats sold at this price. What quantity will be supplied if the price is 72,960? So this is the price we're selling them for. P is price, Q is quantity. So it goes in for P. So the first thing we need to do is get our 2 to the Q by itself. Always think of opposites. Any questions on why I plugged it in here? This was price. This was quantity. I want to get this by itself. This is being multiplied. Do the opposite, divide. I don't know if it doesn't divide evenly, I would keep it till the end. It does divide, so 128. Any questions so far? This one, we have 2 to a variable. So if we take the natural log, we can bring that variable down. Any questions so far? Okay, so if we take the natural log of both sides, we have the natural log of 128. Here, this Q can come down in front because of this one. Any questions? Again, this is multiplied, so to get rid of that natural log of 2, we divide it. This would be our exact value, but since we want the number of boats, we want to plug that into our calculator. Make sure you close your parenthesis on the 128 before you divide by the natural log of 2. And you should get 7. So if the cost is $72,960 per boat, we will produce and sell 7 boats. Any questions? Says officials in state A tend to raise the sales tax in years in which the state faces a budget deficit and then cut the tax when state has a surplus. The graph to the right shows sales tax. Since it was first established in 1933. So this would be 33 when it started, 35, 43, 49. Those are the years. So I want to find the limit as x approaches 52. We would just look where 52 is, 49, about here. Notice that on both sides, it's 3. So at 52, the tax in, looks like cents, was 3 cents. On the test, I have a graph. Well, it doesn't have so many broken spots, but it will have spots. And it asks you where it's discontinuous at. When you're saying where it's discontinuous, it's all the X values. Now I'm only going to name a few because this one has too many, but 35, there's a break. So 1935. 43 has a break because if I'm tracing wherever you have to jump, those are all discontinuous. And I think those are what they labeled, but 43, 49, 67, 74. So all these breaks are where it's discontinuous. This one, it's not discontinuous at 52, it's continuous. And the limit from the right and the left is coming in at the same value, and that's why it's 3 and it doesn't have a plus or a minus. $49, it's discontinuous. 49 is this one here. So we're here and here. Any questions on why it's discontinuous? It's 3 because that would be your y value. So if you go over 52 for your x and go up to the point, it's right here. And it's a solid line on both sides of it. And so that's why it's the y value. As long as it's not an x value where there's a break in the line, it will be whatever the y value would be at that point. But the other one at 49, there's a break. It's this one here. No, the first one is a minus, which means from the left. So go to where 49 is, go a little bit to the left and see which line is above it. It's this one. So our answer is round 1 decimal place. So our answer is 2.5. So we went to where 49 was. We went a little to the left because of the minus sign. We went up and it's at approximately 2.5. The next one has a plus sign, so 49, a little bit larger. Notice that it's the other line, it's this one. And it's at 3. Any questions on that? So you could think of a dotted line here, and this one goes on the right side and this one goes on the left. So the minus is over here. The plus is over here, and it's whatever that y value is. This one's the two-sided limit. Now, if you find the limit from the left and the right, these two in this case are not equal. So this one does not exist. If these two were the same, this would also be the same. And that's what the case was here. If we did the limit from the left and the right, it was all 3, and that's why they didn't ask it. So for the two-sided limit, if you find the limit from the left and the right, if they are not equal, this one does not exist. This last one, T of 49, this one's the shaded in point. So if we go back to 49, the top one is shaded in, the bottom is not. So it's 3. So the shaded in point is at 49.3. So it's 3 cents. Any questions on that? I have another one, yeah, that we'll do on the outline. Actually, there's a couple so that we can practice. Any questions on that one? The last one that's on your exam Looks like this. The cost in dollars for manufacturing a particular DVD is C of X equals 7X plus 13,000. Where X is the number of DVDs produced. Recall from previous chapter the average, and I don't think I have that. You have to know that the average cost function is the function divided by X. So you probably want to put that on your formula sheet. Average cost function then is the function 7X plus 13,000 over X. Any questions? Okay, limits to infinity. For limits to infinity, we look at the degree of the top and the degree of the bottom. What is the degree of the top? Anyone? It's your largest exponent, which in this case is a 1. But if we look at the bottom, the degree is also 1. When the degree of the top and the bottom are the same, you can take your two largest degree terms and reduce them. So you take your two largest degree terms and reduce them. The 13,000 is a large number, but when you're talking about 7 times millions, 13,000 isn't much. So it will approach 7. X was DVDs. And this is average cost, so it's cost per DVD. I will not have this. You have to be able to explain it. As many DVDs, because that's going to infinity, are produced and sold, the cost approaches $7 per DVD. So X is getting large. That's the number of DVDs. As many DVDs are produced and sold, the cost approaches $7 per DVD because we found average cost instead of total cost. Any questions on that? Those are the problems you'll see on the exam. This is on the weekly checklist. A company charges different prices for their chemicals depending on the number of pounds purchased. This is shown in the graph. Oh, it's below now. Number of pounds per chemical is here and total cost is here. For what X value is the graph discontinuous? Well, if I trace, it's discontinuous right here. There's a drop. And that value is here. This is 100, 150, so 125. It is discontinuous at 125. Let's find the limit as X approaches 125 from the right, from the left, two-sided limit, and then the shaded endpoint. Oh, sorry about that. $7 each. What it's letting you know is when you're having them produced, you should be able to find a cost of $7 each, or you need to keep looking. Find a company that will produce them for you. And this one, limit from the right. So we go where the 125 is, which is right here, and go, the plus sign is to the right. So we go a little bit larger. Notice if we put a dotted line here, we'd go to the right side. So that's this graph. Go across the Y value, 175. From the left, go where 125 is, go to the left. That's on this side of the line. That's this graph. And it goes up to 200. This one is not equal. So this one does not exist. Any questions on that part? I know the problem doesn't ask these, but I probably will. Oh, I know I do. Now that I think about it. What is the cost for 125 pounds? This is the same thing as this. It's the shaded in point at 125. If we look, the shaded in point is not this one, it's this one, 200. So the cost for 125 pounds is $200. Any questions on that? If a customer wants to buy 125 pounds, how would you save her money? A couple ways we can do that. Well, to save her money, 125 pounds, if we want a little bit more, 130 because this is 125 pounds. It's shaded in. We went a little bit larger, it drops. So if she purchased 126 pounds, the cost is approximately $175. Which would save her $25. And she'd have another pound. So you want to find where those breaks are, because that's where you can save money. The other thing you could tell her, notice if we go across here, for $200, she could also get 150 pounds. So she could either get 150 pounds for 200 or 126 pounds for 175. Either one would be fine for you to say. Technically, this saves money. This one, you're still spending the same amount of money, but you're getting more. But any questions? Positive. I guess we could look at this one too, because it helps. Yeah, we got time. And then we'll do this one on Wednesday. This is on the take home. The limit as X approaches, for what values is it? First ask for discontinuous. For what values of X is the graph discontinuous? Just trace wherever there's an open circle or a jump. Right here, I'd have to jump. So it's discontinuous at -2. Tracing, it's discontinuous here at 3. So those are the only places where there's a break in the line. First one, we're doing at -2. On the test, there's only one of these, and it's probably more like the last one we just did. But I think this needs the most practice. So at -2, we're here. Now, if you want, you can draw a dotted line. The limit as X approaches -2, the plus sign means from the right. So you go to the dotted line, you go to the right, it's here at 1. But -2 from the left is also going in at the same spot. From the right and from the left, we're going in at 1 for the Y value. Because these two are equal, this one is the same value. So either all 3 of these are the same, or this one doesn't exist. This last one's the shaded in point. Notice that there's no shaded in point at -2. So this does not exist. If there was one, say there was one here at 3, then the answer would be 3. But there's no shaded in point, does not exist. Well, we'll do it real quick. The next one's at 3. If you look at 3, we go a little to the right, it's this line, because this is the plus sign. And the answer is 2. So these are all Y values. To the right, we're up here at 2. The next one is the left, because of the minus sign a little smaller. We're down here at 1. These two are not equal. This one does not exist. The last one's the shaded in point, and the shaded in point is this one at 2. Any questions on that? Okay, so see which ones you have questions on the take home, or if you need to see any more of these. But the 5 on the test are definitely similar to the My Math Labs. So you can go on those, try them, keep asking for another one, but they are not for a grade, so you don't have to do that. Any questions? No? There we go. I also recorded that, so